So in the sixth video, now we're going to talk about the power of a product property and also the power of a quotient property. So now we're starting to combine multiple properties to simplify problems. So first of all, the power of a product is if I have a product of two factors inside parentheses raised to a power on the outside, each factor must be raised to that power. So it's similar to the distributive property, but it's a power over a product. So again, if in algebra, if I have a times b to the nth power, then that means the a must be raised to the nth power, and the b must also be raised to that nth power. So, for example, in number 1 here, the 2 has to be raised to the third power, the x to the fourth must be raised to the third power, and the y must be raised to the third power. So now we evaluate 2 to the third is 8. If you notice, x to the fourth all to the third requires us to use the power of a power property, so we simplify that by multiplying those exponents, that's x to the 12th and y to the third. And now that's completely simplified. In this next one, we have a negative 3 in the parentheses, so that negative 3 must be raised to the second power. The x to the negative first must be raised to the second power. And again, the y must be raised to the second power. Well, negative 3 in parentheses raised to an even power is a positive 9. Negative 1 times 2 would be x to the negative second, and then y to the second. Now again, we can't leave a negative exponent, so we have to simplify this by writing it as 9y to the second, and then moving the x exponent downstairs to make it a positive power. And now there's my final answer. All right? So that's using the power of a power property, and then sometimes also, the power of a product property, and then having to use the power of a power property to also help us simplify things. And then the last property here is the power of a quotient property, where we have a fraction that's also raised to an exponent. And in this case, the numerator must be raised to that power, and the denominator must also be raised to that power. So you can see that using numbers, you can see that in algebra. So in this problem here, we have that everything inside the parentheses must be raised to the fourth power. So the 3 must be raised to the fourth power, the x to the fifth must be raised to the fourth power, and the 2 must be raised to the fourth power. And now we evaluate. 3 to the fourth would be 81. Now I have power to power here, so that'd be x to the 20th power. All over 2 to the fourth would be 16. And then there's my final answer. Now this last one. Now there's a couple different ways that you can handle this negative exponent here, but we'll go ahead and just distribute it to each factor. So that's 2 to the negative fifth, x to the negative fifth, and now the 3 must be raised to the negative fifth power. Now remember, we can't have negative exponents, so we're now going to rewrite these so there are no negative exponents. So this is 3 to the positive fifth. The 2 would be downstairs to the positive fifth, and then the x has to move downstairs to be to the positive fifth power. So now 3 to the fifth is 243 over 2 to the fifth is 32, x to the fifth power. And now we have our final answer with no negative